Hello students, I welcome you all for the lecture series on production technology. So in this particular lecture, we will discuss about the plastic deformation theory and mechanical working of metals. So in the previous lectures, we discussed about casting and welding processes. So they are basically metal creation process or metal addition process. So in casting, we create new material. And similarly in welding, we add two or more metals together. Uh, a major difference between the cast part and the metalworking part is that strength plays a role here. So imagine what are components you are using in an everyday life, be it your objects surrounding you, desk, tables, knife, fork, spoon, table, plates, etc. Everything. They are made from some metal forming process, metal working process rather than directly from casting. So if you have noticed that, you would have seen that everything which we use is made from some metal working process. So what is metal working actually? So why we have to do metal working? So let's uh, analyze that first. So metal working is the process of uh, introducing some form of deformation or some form of stress into the metal. So why we are doing that is to make the metal work. We are working the metal. So why we are working the metal is to change the grain structure of the metal. So if you see a metal which is made using casting, the grains will be very large. Large grains usually indicate that it will be hard. It will be very hard. At the same time, it will be brittle. So parts produced by casting will be hard and brittle. But our day-to-day applications require materials which are ductile. For example, if you need to make a desk or a table, you need metal which is ductile rather than brittle material, because you cannot bend the brittle material. The metal has to have some form of ductility. So that's why we are going for metal working. So predominantly there are two different types of metal working process. One is hot working and second one is cold working. So how we differentiate hot working and cold working, we'll see now. So before that, let's see the different types of metal forming process. Rather, we will get to this later. So first, we will see about the recrystallization temperature. So what does this temperature actually signify is that it's a temperature at which new grains are formed. So I will explain to you about the recrystallization process in the upcoming lecture videos. Since in this whole unit we'll be learning about this, just make a note that it's a temperature at which new grains are formed, and this recrystallization temperature is approximately half that of the melting point of the metal. So now let's get into the introduction again. So metal forming process can be classified into two major parts. One is bulk deformation and another one is sheet metal. In the same way, our unit is also being classified. First, we will see about the different bulk deformation process such as rolling, forging, extrusion and wire drawing. And then we will get into the sheet metal forming. So what is a sheet metal is that a metal which has a thickness which is less than 6 mm. So if you have any material which has thickness less than 6 mm, you can actually call it as 6 mm. So greater than 6 mm, you can call it as plates. So that's the difference between this sheet metal and the plate. So we will first see about the bulk deformation and then we will get into the metal deformation process. So before getting into that, we are speaking about deformation. So what is actually deformation? Deformation is nothing but it is the change in shape of a material. So when you change the shape of material, you may either bend it, you may either twist it, you may either pull it, compress it. So whatever action you are doing, the general term is deformation. So there are two types of deformation. One is elastic deformation and another one is plastic deformation. So elastic deformation, as you see, I'm going to change this video. Yeah. So if you see the graph, this is a stress strain graph, which shows you the various range or interaction between the stress and strain. If you see here, up to this point, the graph is actually linear. So it is increasing linearly, and at this point there is actually a point called as yield point. So what happens here is that yielding starts to happen. Yielding is nothing but it's giving away. So from this yield point we can define the elastic and plastic deformation. So up to this point you will be having elastic deformation. So up to this point, this signifies elastic deformation. So what is elastic deformation? As the name indicates, elastic means when you apply the load, when you apply the tensile load, it will stretch, and once you remove the load, it will go back to its original position. So that deformation is called as elastic deformation. As you can see, an example of elastic deformation is stretching a rubber band. But plastic deformation is a irreversible deformation. So once you apply load and remove the load, the material will remain the same. So you can take the example of folding a paper. If you apply small load and remove it, paper will get back to its original position. But if you fold it, then you cannot take it to its original position. So that's the difference between this elastic and plastic deformation. So with this short introduction, we will get into the actual metal deformation process in the next video. Thank you, students.